All right, so section 10.6, we're dealing with more angle-arc theorems. Aren't you excited? More theorems to remember, more formulas dealing with arcs and angles. Actually, these ones aren't that bad. Theorems 89 and 90 pretty much relate your inscribed angle and your tangent chord angle, and saying that since they have the same formula to figure out the measure of the angle based off of the arc that they create, if you know that the angles are congruent, then you'll know the arcs are congruent. Or if you know the arcs are congruent, then the angles are congruent. So it could be two inscribed angles that share the same arc or have congruent arcs, or it could be an inscribed angle and a tangent chord angle that share the same arc or have congruent arcs that will make the angles congruent. So in this example, say we knew that arc CD is congruent to arc HG, then we would be able to say that angle B is congruent to angle IHG. Likewise, you could go the other way. You could say if you know that these angles are congruent, so angle B congruent to angle IHG, then you would be able to say that the arcs are congruent. Okay, so just think, it should make sense. They both have the same formula that to figure out this angle, it's half of the arc. So if the arcs are the same, then the angles have to be the same, right? Okay, here's another theorem. This one's cool. We already kind of know this. It says that if an angle is inscribed in a semicircle, that it's going to be a right angle. Well, now technically I don't need to have this part of the circle. If we just kind of ignore that, from this line, which is the diameter, and this arc, that would make a semicircle. So if you have an angle that's inscribed in it, that would be this angle right here, so the vertex is actually on the circle. They're saying that this angle has to be a right angle. So if you think about this, if we had the entire circle, this arc right here is going to measure 180 degrees. And if this arc is 180 degrees, an inscribed arc is half, or an inscribed angle, rather, is half of the arc. So half of 180 is going to be 90. So we could go ahead and just say this. All right, so that'll be useful because now you have a right triangle that maybe you know this side and you know this side and you want to find the radius, so you can figure out this whole length, Pythagorean triple perhaps, and then go from there. Okay, next one. This one's more interesting. Okay, theorem 92 says that the sum of the measures of a tangent-tangent angle, so that would be angle A right here, and its minor arc, so that would be this tiny arc right here, HG, is always going to be 180 degrees. So this angle and arc are supplementary. They add up to be 180. So let's actually go through and figure out why. So if I let this arc have a measure of x, then the other arc, the major arc over here, would have to be 360 minus x. Now, the formula to figure out angle A, if you recall from the last section, is that you take half of the major arc minus the smaller arc, or the minor arc. So if we use that formula, 1/2 360 minus x minus x, you can go through and figure this out. If we subtract these two together, we get negative 2x. Take half of that, you get 180 minus x. All right, so that's kind of interesting. So let's put this into practice here. Here's an example. It says that in circle P, the diameter BC, and let's see, AC is 12 and BA is 16. We are asked to figure out the radius of this circle, so like from P to C. So if we, oh, interesting, okay. So if we plug in these two lengths that they've given us, and we know that this is an inscribed angle, this being the diameter, that angle A is going to be a right angle. Oops, that was really poor, but whatever. Okay, so we can use our Pythagorean triples. That now we know that BC is going to be 20. And so if BC is 20, that's the diameter. We want the radius. We just take half of that, so the radius is 10. Okay, so here's the second example. It says that given PQ and PR are tangent segments, and we know that arc QR is 163 degrees, find the measure of angle P and the measure of angle PQR. Okay, so first of all, we know that angle P is going to be half of this arc, because these are two tangent segments, and using this theorem that we have up here, we know they're supplementary. So 180 minus 163, we get angle P is 17. Okay, now using our two tangent theorem from before, since these are both tangents, they're both congruent. So now we know that this is an isosceles triangle. And if we know this angle is 17, these two angles are congruent. They have to add up with 17 to be 180, because a triangle, all the angles add up to be 180. So angle PQR is going to be half of 163. Since this angle and this angle added up is 180 minus 17, which is that 163. So half of 163, we get 81.5. So that's not too bad. Okay, that's it for section 6. Hopefully that wasn't too long. Let's see. And we're done. 6 minutes, not bad.